Awesome. Hey, everyone. I'm Karthik. I'm going to be talking about ordering sovereign applications, and I'm co-founder of Sorella. We're designing more competitive, decentralized, and fair auction systems in the Ethereum ecosystem broadly. So just a bit of a roadmap. First, a quick refresher. I promise I'll make it quick on what MEV is. Then we'll talk about the attribution problem, and then what I think is the end game for application design generally, which is the sovereign application, or towards very MEV-aware, maximally competitive, and efficient applications. Okay, so the first type of MEV that we all know is sandwiching. And basically, a user is going to submit an order, it's going to go to a public mempool, and there are two scenarios that we can look at. In scenario one, the user submits this transaction, and assuming the previous block, all the arbitrage was done correctly, so the pool price that they're touching was reset to whatever the true price was at that time. They submit a very naive order, so a limit order with a lot of implied slippage, but just like as a function of how the block was constructed, they're the first one to touch the pool. They're going to get a pretty good price because it's transacting against whatever the true price last block was, and given that it's like random which side they're on, either bid or ask, they're either going to be facing minimal ex post regret if they're on the opposite side, or they will be better off. They'll get better execution quality than they would even on a centralized exchange. In scenario two, now we have people monitoring the mempool, realizing that this is a naive transaction with a huge slippage tolerance, and now they are going to want to sandwich it, right? They're basically going to want to fill this user at their limit price and then take the liquidity from the pool. The LPs will get the delta of the three swaps of the pool, and the arbitrager will basically get whatever was lost by the naive swapper. Given that this is a deterministic opportunity, now a market forms, right, where everyone sees this transaction and they bid up to the true value of the extraction to the block builder for block space. And this value basically flows from the user submitting the transaction to the builder and then eventually to the proposer. But it is captured theoretically in the competitive market we've created. Now for a more sophisticated form of arbitrage, sexdex, right? What happens here is that information's accruing outside of L1 blocks. So very different than sandwiching previously, when basically the extraction was done based on the granularity of the block on a transaction by transaction basis. Here, right now, consensus takes time. It takes 12 seconds on Ethereum mainnet. And in this time, lots can happen off-chain. Information accrues, and as a result, there is arbitrage to be extracted. So the idea for sexdex is, in these 12 seconds, price on Binance is very volatile. A sophisticated arbitrager with both inventory on the centralized exchange as well as on-chain is going to see this price discrepancy, and they're going to want to transact against the Uniswap LPs who have a stale price, right? It's basically the state of the previous block, which is very different from what is currently happening in the world. And they're going to bid against all of the other sophisticated players for this opportunity to be the first one to touch this pool. And again, this value is captured in the competitive market. So now the attribution problem. Who's MEV? Where's it going? Why is this bad? So let's look at the value flow of the systems we've built, right? We realize that MEV is a huge problem, that it takes some level of sophistication to actually extract, but we have the guardrails and infrastructure in place to make sure that this is encompassed and collected in a competitive auction, and also distributed to some party, right? Right now at the bottom of the totem pole, we have the passive players, the retail players, passive LPs, and uninformed traders. They're not having very fun in the current system. So they're submitting transactions, or they're just holding passive pool liquidity. And the two types of arbitrage being extracted, as mentioned, are like atomic, so bundling, sandwiching, and then sexdex. And then these are done by searchers who then bid up this value for what they can extract to the builders for actual block space. The builders then solve this combinatorial auction where they build the most valuable block they can, and they're competing with each other, have various moats being integrated, private order flow, et cetera, but they're all competing for the most valuable block that they can create, and they're bidding this value back to the proposer, who's the decentralized party. This is the kind of goal of having PBS, right, where proposers can be decentralized, get the value, but being cognizant that block building is very difficult and it will centralize, and it's just inevitability in the current system that we're in. So this market's theoretically efficient. It should capture all of the value that is being set forth by the unsophisticated players. But the issue is that it's all encompassing, right? It's basically one lump sum for everything I can extract in this given block, and that goes to the proposer. It lacks granularity for how we can best redistribute this value to the truly adversely selected parties. Even though we form the competitive market, there's no redistribution. And analogously, you can think about this in like a shared sequencing world for the L2s. If I'm sequencing multiple L2 blocks, now presumably there's some user on a DEX on one of the L2s who swapped and got really worse than like what they should have deserved execution quality-wise. Now there is the resultant arbitrage between the two L2s to sequence both and then reset the DEXs to whatever the mid-price is. In this case, if you sell off the sequencing rights for both L2s, this value is going to opaque parties, maybe distributed pro rata for the token holders of each L2 chain. But the the swapper that caused this value to occur in the first place, they're not happy, right? From their perspective, what does this look like? They basically send a naive swap, and they know that there is this competitive market that forms due to how much value is left on the table. But all of this goes to the stakers. So it's basically like, or in the L2 example, it would go to the token holders of both chains. But the idea is that the user is paying to use the chain, and they're getting screwed over based on the current dynamics, microstructure, et cetera, of stuff happening on chain. And not only do they get screwed over, but they're actually paying the stakers of the protocol they get screwed over on. So the incentive system's completely misaligned, and that is why I think the end game for application design will be the sovereign application. So just some definitions to get out of the way. First is an attributable app, right? An attributable app is an application that can uniquely pinpoint the exact players in the application, what each of them is trying to do strategically to maximize their value, and is designed so that now you have a competitive auction like we currently have, but you're able to redistribute the value of this competitive auction exactly to where it needs to be, right, to the adversely selected party. An example of this is a uniform clearing batch auction. So the idea here is that you let all of the ask and bid side demand aggregate over the course of a block. You do this for both user orders, so swap orders that are basically limit orders, and you also do this for the underlying pool liquidity. The idea here is that you also enforce everything to be executed at uniform clearing price. So now the game for the searchers, instead of competing against each other for block space that escapes to some arbitrary third party, or instead of competing against each other for latency races to be the first to fill orders in a first come, first served manner, now they're competing against each other for the best price to clear the batch. And this will converge to whatever the true price is in a truly competitive setting. But this is notably and very importantly redistributed back to the underlying uninformed parties of the application, so the LPs and the swappers. Another is MEV taxes, right? So this is Dan Robinson and Dave White's design that you can implement on priority ordering, or priority order sequencers. And the idea here is that these sequencers already order transactions by priority. So the applications built on top of these L2s would essentially specify with the sequencer that they would take some fraction of the priority fee paid to be like the first presumably to interact with the application, right? So the idea would be in the case of a LVR mitigating application that you would impose a tax on the first transaction that goes through the pool, and you would bid this back pro rata to the LPs. So the idea is that the application has a more granular viewpoint of who's actually the adversely selected party within their specific application setting, and if they're able to contain this value, they can aptly choose who gets it. So all these systems need maximal participation, thus maximal decentralization, and minimal barriers to entry, right? You ideally want it so that it's not like right now where integrated searchers are currently dominating because they're sequencing the entire block, and they also have, I don't know, 80 tokens on centralized exchanges that if there's volatility in any of them, now they have an edge and can just price out any competition for a searcher who per se just wants to trade one pair, right? If you're able to design these systems well, you can do it on a pair-by-pair basis enforce uniform clearing price for all the pairs and make sure that anyone, even me, with just ETH and USDC on a centralized exchange, I can participate in the SexX ARB for just that pair and be as competitive as an integrated builder. The issue with attributable apps right now, especially like the priority ordering model and MEV taxes, is that there is second order MEV that cannot be attributed. So this is the idea that I can still have the same composability dynamics as a searcher across multiple apps. And now, given my desire to transact for multiple apps, I have some value for this, right, that I pay to the builder, let's say. And we cannot say for sure which application I'm actually taking more value from, right? So this is defined in a very small subset of the MEV tax use cases. I think it's like only for the linear MEV tax applications, where you can aptly say, okay, if I need this priority for both these applications, now if we go pro rata, it's perfectly fair for all parties. In general, this becomes combinatorial. Second, you have this notion of combinatorial auctions. It's very, very difficult to actually attribute who should get the value. So now is a new type of app, a sovereign application. These are applications that lock their state and are not atomically composable with other applications. They order themselves, so either naively, like first come, first serve, or strategically, like a fair ordering mechanism like Themis, or a uniform clearing price enforcement, something like this. A good example mental model to have for this is kind of like L2s, right? I would say a lot of L2 builders would cringe at the fact that they're being called apps, but the idea is that they are not composable with other apps, other L2s. They sequence themselves, they have sovereignty over their sequencing, and they post state routes to the L1 for settlement there. So the golden intersection here are apps that are both attributable and sovereign, right? Sovereignty without attributability will always incentivize fairer applications to be built on top. So this is the example with L2s. They're sovereign, but they don't have attributability. There's so much in the design space of L2s with regards to sequencing, so many different apps built in them, and different adversely selected parties within these apps. If I am able to sequence, let's say, both Optimus and Arbitrum in one lump sum, and I have some value that comes from the maximal extractive sequencing, I don't know who to actually distribute this value to, right? Because there's so many counterparties that are being arbed on both L2s. On the other hand, attributability without sovereignty leaks values to other apps via composability. So this is the example of the MEV taxes, and with composability, why it doesn't work as effectively as it would want to. The idea here is that you would always be getting arbed against other apps in your domain, and there's a game to be played between applications to set their MEV tax so that they're taking MEV more so from the other applications, but at the cost of perhaps their own users. So this is like uncharted design space, and it's unclear whether this will have a good equilibrium. The future apps, inevitably, in my opinion, will be both attributable and sovereign. The idea is that it's better prices for users. So these are the most competitive applications with the incentives that facilitate maximal fairness for users, whether that's uniform clearing, whether that is the proper amount repaid to a Dutch auction user, a liquid AT, et cetera. Easier competition for solvers because it's essentially a one-stop shop, right? They have some edge in terms of some market, and they can only market make on that specific market without having to worry about any of the other dynamics going on with the chain generally. And the good thing for applications is that it monopolizes. So if you have sovereignty over your sequencing and your application state, and you actually see PMF, now it's very difficult to compete because you're not sovereign with other applications, or you're not composable with other applications. You won't see any leakage to other applications via composability. And given that you have the first mover advantage, have PMF here, and you control your app state, feasibly you'll be able to show that you offer better execution quality than your competitors, and more users will move to you, which creates a positive feedback loop, a pinwheel of sorts, that is difficult to stop. So just zooming out a bit, a mental model I like to have for MEV is framing it with regards to commutativity. The idea is that anytime I have transaction 1 and transaction 2 in that order, and there is a different value to be had when sequenced in transaction 2 and then transaction 1, now there's a market built on top for the rights to sequence in whatever which way, right? So ordering non-commutativity creates this market for ordering MEV. Attributable apps, on the other hand, with uniform payoffs, uniform clearing price, within the application setting, they are they're commutative, right? So the idea is consider a uniform clearing price DEX. Now the searchers will be competing to clear the batch at the best possible price, but it will be the same price for not only their transactions, but also all users within the DEX, right? All swappers and the underlying LPs as well. And now you can basically sequence all of the user swaps along with the searcher swap in any which order, but since they're getting the uniform clearing price, there's no value to be gained from the actual ordering of these trades. The attributable plus sovereign intersection with no equivocation faults on behalf of users results in a application that's both internally and externally commutative. So what does that mean? Internally is basically the uniform clearing price example, right? If the application is designed properly. Externally commutative is a result of the application controlling its state. So it has a state lock essentially. And given that it is the only application, the only application that can touch this state of the blockchain, and it sequences in the uniform clearing manner, now not only is it internally commutative with its orders, but it's kind of like a module that exists in the block and can be sequenced anywhere within the block, but it doesn't matter because wherever you sequence it, it's going to be the same end state before and after it executes, given that it controls its own state. So in the asymptote of kind of my thesis for the endgame of app design, if all applications become both attributable and sovereign, then all present value leakage will be internalized within the application level. This will make really, really poignant use cases on the user perspective of using these decentralized applications for tapping into the most efficient, fair, competitive market that exists, I think, generally. But it also has minimal, if not any, leakage to the end proposer via ordering, right? So given that all of these applications form these application-specific subsections, modules within a block, and they're all commutative with each other, there's no value to be created from ordering them in some which way. So now all of the value going to the proposer is purely just the base fees, right? And this is desired because this is what they should be getting. This is basically a testament to the supply side of what blockchains offer, which is decentralized block space, which is what they're getting. So here's how this would kind of look like. There are two examples, two apps. One is spot liquidity, DEX, and then the other is perp exchange, and this is a centralized sequencer with MEV taxes. So the users submit their transactions, in the case of app 1, to some restaked network of nodes, app 2 to the centralized sequencer. There are searchers that are also monitoring this mempool, right? So they're either running a node in the case of app 1, or they're plugged into a node in the case of app 1, or in app 2, they're just getting a feed from the sequencer. And they're acting with regards to both information they're seeing from users in the mempool, along with any exogenous information that's accruing in between the block times. And they're acting in a way that's obviously competitive with each other, and this is going to result in uniform clearing both on the spot and perp application. This is going to be sequenced this way from the actual consensus mechanism for app 1 and from trusting the sequencer with MEV taxes for app 2. But the idea is that both would have uniform clearing price if everything functions properly. In the case of app 1, you'd also just have like a quorum certificate along with this bundle. App 2, the centralized sequencer is the only one who can touch the contract. So they're the only one who can submit this, and you basically have to trust that they didn't censor and went about this properly. Now the end block is going to have both of them, but the beauty is that they're commutative with each other along with everything else in the block, right? They're agnostic to their position in the block, and thus, even though you have this system where there would have been a lot of MEV extracted if the user just naively sent their orders to the public mempool for inclusion in the block, with composable applications, now given that they are sending their transactions to attributable and sovereign applications, they get the best possible price and don't even have to pay a high inclusion fee, right? They're just paying base fee plus epsilon for inclusion because the block builder is more than happy to include them knowing that this doesn't touch any contentious state. So some open questions. We definitely need infrastructure to ensure no equivocations, right? It would be really bad if a user submits an order and it is included in like the canonical sequence in a application-specific module, and then they basically send a transaction with the same nonce, and that gets sequenced first, which invalidates the entire bundle. The idea here is that this probably wouldn't happen because the aggregate weight of this bundle is non-trivial at all, given all the users that are using it. But also, we can just have something abstracted on top to prevent this from happening, like a new standard. Another thing that I've been thinking about is how does this catalyze parallel block building? So from like distributed systems literature generally, if you have state locks, you are able to parallelize very efficiently, right? So is there a way for us to parallelize block building where we have something like a optimistic state lock of sort with some crypto economic security, and what are the benefits of this? Would it be able to compete with something like Solana in terms of UX, for example? And the other is pre-confirmations for app space. So when is it useful? What is the strategy for applications wanting settlement on whatever the destination chain is to bid for pre-confs? How long in advance should they bid for it? Essentially, what I think this will converge to is like a volume feature on what the L1 proposers think that the volume of users in the application at any specific time will be. Can we price this efficiently? Will there be a competitive market? And will there be demand for the applications to actually opt into this to guarantee their kind of section of the block for future blocks where it's just their application in the bundle that has uniform clearing? But yeah, no, thank you so much for your time, and it was a pleasure.
I assume you can't route through multiple pools, like as a searcher, like submitting an atomic bundle in Sorella. Like, I'm curious what the extent of value leakage is from the fact that you can't do that because of attribution issues.
Right. So it becomes stat arb, right, where you can route through multiple pools, and you don't want to route through multiple pools due to the attribution issue. The problem for the solvers would basically be in Sorella's pool that has a lock on its state, we know from whatever the centralized exchange price is that this is a good signal on where this on-chain pool is going to execute, right? So let's say I want to route through some number of pools, and then one of them happens to be a pair that is also a Sorella pool. And I also have a view of whatever the off-chain price is with a correlation to what I think, given my swap volume, will be the price of this executing on Sorella's pool. Then it's a stat arb problem on my part to basically do all of the legs except that one leg, source that one leg out of my own inventory, and then place the subsequent limit order on Sorella that captures the spread and would be positive for me in expectation, given that I have like a lot of capital and stuff. But this is a problem that thankfully market makers in traditional finance at least have solved a lot for a very long time with a lot of existing infrastructure and pricing models that do it very well.
Makes sense.
Any other questions for Karthik?
Awesome.
Maybe while Drew's still getting set up, maybe comment on, I mean, it sounds like, as you pointed out yourself, having this application-specific sequencing is very similar to being your own roll-up. So what are some of, I mean, what is, if you could compare and contrast being your own application-specific roll-up versus the model that you're describing?
Right. So in the own app-specific roll-up, I think in the model I'm describing, you are able to have these kind of lateral applications where you can sequence one application across many different rollups and have interoperability as a function of the application within these rollups without having to kind of like silo your own state and then force interop to you and then out of you for one use case in your application. You can have this kind of existing on all layers, presumably as like a base facilitating of liquidity between all of the siloed L2s. And then this would have the unlock of then being able to let users have like the interop they want, right? Where I have some amount of an asset on Optimism, I want to swap it and bridge it at the same time. I can go to this one lateral application across all the L2s that is a canonical spot liquidity marketplace where all the market makers are integrated, and I can do this kind of in like a one block time frame. Now I have whatever asset I wanted on the destination chain, and then I can go buy an NFT or something. So you don't have like the atomic composability that something like shared sequencing would guarantee. That being said, given the ease of building on top of shared sequencing, I think it's very much complementary. And also, the users would opt into a system like this because they'd be fine waiting an extra 200 milliseconds, given that they're getting better prices and there's less extraction from their positions at the end of the day.